Okay, I got a January 2008 Edexcel exam. I'm looking at question number 6, which is a vector question. Now, we've got 2 points which are given by position vectors A and B. Okay, and the first part of this question, what we really want to do is to find if both of these points here are really leading us to the second point, which is the vector equation for the line. So this step is to help us with B here. So let's have a look at doing A first then. Okay, now AB written like this means, written like this here, AB written like that means from A, which is given here, to B. So A is at the end of your position vector, it's just a point. Yeah, B is just a point here, and we've got to go from there to there. So we're going to have to go minus A, because you're going backwards along A, and plus B, okay? So that's why that's like that. Now, you can easy enough just go back to work this out. All we do is just take that's B, okay, so it's 3i minus 2i, okay, 4j minus 6j, k minus k, okay. Think about that. That's all I've done to get these numbers here, right? Now the second part is to work out the line. So what we're going to do here, what I'm saying, okay, this line works out as going up B, oof, not doing very well there, and then anywhere along, okay, and then moving along here by some arbitrary distance, which is input via this L1. Okay, the L1 is just moving us along this line. So we take B, which is straight from the question, yeah, we just read that straight from the top here. I'll scroll up and show you again. That's just B here. Okay, and then we're saying the next thing we do, we move along, we go to B and then we move along B minus A by some distance specified by this L1 here. Okay, not technically the distance you moved along, okay, so that would be a unit vector if that was the case, but it moves us along by effectively the size of this vector times L1, right? So it shifts us along is what it does. Okay, so the vector equation of line L2. Okay, now I've only put this in because I'm saying I'm going through the origin. The other thing I'm told is it's parallel to I plus k. Okay, so if it's parallel to it, then it's going through the origin. Then I've got effectively this here. Okay, this is effectively this different line. Okay, this is kind of the direction it moves along the line. Okay, and here we're told it moves along the line in this direction because it's parallel to that. Okay, and again this is just specifying how far you moved along the line. Okay, and here we're just using the dot product rule. So we're looking at the direction, or the vector that the direction effectively. This is the direction of the line. Okay, which is given by this here and this here. There's a direction we're moving along the line. We're moving along the line B minus A, yeah? Well, here we're moving along the line I plus K. That's the direction what we want. We're going to put that there, put that there. Okay, and we're doing the dot product rule. So all we're saying is A dot B equals A mod times B mod cos theta. Okay? That's all we're doing there. So we put that in, and to do the dots of two vectors like this, you dot the I with the I over here, you dot the J with the J over here. There isn't one. Okay, the reason being that if you dot, you wouldn't consider, for example, dotting the J with the I, because they're orthogonal to each other, so they'll always be 0. So you only need to look at the I's, the J's, and the K's separately. So you're going to get 1 for this first one, and then you can see there's no J because there's no J over here, and there's a K there with a K there, so that would be the 1 plus the 2. Okay, if we go to the other side, then what have I done here? Well, I've found the modulus of this. I've just squared these and added them up, and then square rooted them. So 1 squared plus 4 squared plus 4 squared is 9. 1 squared plus 1 squared is 2. Root 2. It's given us 3 there. Okay, 3 root 2 over there. Okay, and I think you can see as it's going here. This is pretty much just, yeah. We cancel the 3's from the previous one. Yeah, we cancel the 3's there. Then this is just a 1 by 1 root, root 2 kind of standard answer, which is going to give us theta equals 45 degrees. Okay, so when the lines intersect, we have to basically put the equation here. Yep. Equation we got from here, which is this. Yeah, equal to this. We'll find out what L1 and L2 come to. All right. So we do that there. We just And yeah, and the next step is to basically equate your i's here with the i's over here. So here you got 3 plus lambda 1 in front of the coefficient of this I equals lambda 2. Okay, 4 minus 2 lambda 2 equals 0, and so forth. And you can see from number 2 is quite a useful one. Okay, it was the one we've used first because we could straight away say that lambda 1 equals 2. Now if I substitute that back into 1, we've got lambda 1 is 2, and I can clearly see that lambda 2 is 5. Alright. Now if you substitute those into 3, you'll see it's consistent, so we're all okay. So you put our 5, our lambda 2 equals 5. I think it's easiest to use this line, yeah, because you don't have to do any adding up really. We've got it straight, we've got what lambda 2 is, that's all we really need to know. The intersection point is that. Okay, thank you, I hope that was helpful.